All right, so question 2, we're gonna measure the sides of the 4 similar right triangles in millimeters, and we're gonna record the side length measurements in the table. And remember, you will get different answers here because you didn't draw your line segments in exactly the same place I did, and that's okay. Okay? It's okay because when we get our different side lengths here and here and here, when we divide them down here, we'll start getting the same answers. Okay? This is where you want to get the same answers, but up here, it's okay to get different answers. Okay? So I'm going to measure, and then you're going to measure, and we'll compare. So I got I'm just going to measure all of them all at once. Just get it over with. So I got AB. This one looks to me like it's about 19. I know that these are going to be side lengths, so I'm just going to skip putting the MMs. Okay, this one looks to be about 35. This one looks to be about 43. And this one looks to be about 59. Okay, and let's get this one. This one looks to be about 33. And this one looks to be about 60. This one is 83. And this one is 103. And then let's get our hypotenuses. Okay, I've got one at 37. And then this one is at 69. This one looks like it's about 90. It's really kind of in between, but it's close enough. 90, and then this last one is at 119 up here. Okay. So now I'm going to start filling in my table. What did I get? Oh, and I'm going to go ahead and start labeling these too. So we know that all of these are the hypotenuses, right? All of these are the hypotenuses. And then all of these are the sides opposite, right? So this is opposite, 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 because this is my reference angle right here, right? So opposite. And then the one that's adjacent is the one that's touching it, but is not the hypotenuse, right? So this one's adjacent, this one's adjacent, this one's adjacent, and this one's adjacent. Okay, so now I'm going to start filling in the table. I want the length of the side opposite angle P in the big triangle, PQR. Okay, so that one was 59 for me. PEF, that's the next biggest one. That one was 43. PCD, that's the next biggest one. That was 35. And then the smallest one, this should say, it looks like it's F, but it's actually cut off. That's PAB. That is 19. And those are the sides opposite. Okay, now the sides adjacent. The big one for PQR was 103. And then the next one was 83. Then the next one was 60. And then 33. Then my hypotenuses, going from biggest to smallest basically, was 119. Then I had 90. Then I had 69. And then I had 37. Okay, so now I'm going to start dividing stuff. So I want to do the opposite divided by the hypotenuse. So I want to do 59 divided by 119. So let's do that on a calculator. And remember, you're getting different answers because you're plugging in different numbers, but the decimal that we get should be the same. So I'm getting 0.496. Okay. Let's try the next one, 43 over 90. Okay. So I'm getting 43 over 90. That's pretty close to 0.478. Okay. And then PCD, that's the next one. This is going to be 35 over 69. Right, 35 over 69. 0.507. And then the last one is 19 divided by 37. I get 19 divided by 37. I get 0.514. Okay, I'm starting to notice a pattern. It looks like these are all hovering about 0.50. And if you remember our thing about 30, 60, 90 right triangles, remember that if this is our 30-degree angle, then if this is x, then this is 2x, right? The hypotenuse is twice as long as the shortest leg, right? So this means that x divided by 2x is the same as, right, this is basically 1x. The x's cancel out, and I should get 1 over 2, or 0.50. So if I drew this triangle perfectly, you know, like with laser precision, I should get 0.50. Okay, now let's do the side adjacent. And so this is going to be adjacent divided by hypotenuse. So I'm doing each of these ratios. 103 over 119. Remember, your answers are different, but your decimals should all be pretty close to what I'm getting. 103 divided by 119 is 0.866. And then the next one is 83 over 90. 0.922. And then the next one is 60 over 69. Let's see, 60 over 69, 0.870. And then the last one is 33 over 37. And we get 0.892. Okay, so it looks like these are all hovering about, you know, 0.8 something, close to 0.90, but a little bit less than that. And if we remember from our 30, 60, 90 right triangles, if this is x and this is 2x, this should be x rad 3, right? Or if we basically simplify this triangle, if this is 1, this is 2, this should be rad 3. So if I'm doing the adjacent divided by the hypotenuse, I'm basically doing rad 3 over 2. And what I should be getting is I should be getting something very close to rad 3 divided by 2, which is 0.866. And that is that's exactly what I got for the very first one. That's pretty close. So all of those answers should be pretty close to this. And then the last one is I want the opposite over the adjacent. Right? So I want the opposites over the adjacents. So I want to do the first one. I want to do 59 over 103. And I'm going to get 103, 0.573. Okay, let's do the next one. I got 43 over 83. 43 over 83. This is about 0.518. And then the next one is 35 over 60. And again, that's about 0.583. And then the last one is 19 over 33. This is about 0.576. So I'm noticing that all of these are 0.5 something. It looks like it's hovering around the middle, like 0.57-ish, somewhere around there. And if I look at my 30, 60, 90 right triangle, if I have the side opposite divided by the side adjacent, right, that's going to be looking something like this. Here's my 1, here's my 3. I want opposite divided by adjacent. So that's going to be 1 over rad 3. And what is 1 over rad 3? 1 divided by square root of 3. I should be getting, oh, look at that, 0.577. That is almost exactly what I got right here. So I should be getting numbers that are close to 0.577. All right, so it didn't matter how big or small I made my triangle, all of my ratios stayed the same, or they were very close, because there's always like imperfections with measurement. But that's basically the key point, is that the ratios are constant.